4.5. We started on Monday, correct? We solved our polynomial equations. We would factor them, use the zero product property, set our factors equal to 0, and get our solutions or our roots or our zeros, correct? Y'all kind of remember that from Monday? So we're moving on to the second part of 4.5 today. We're talking all about this thing called the rational root theorem. So I want to write this down. Just listen to this real quick. Okay? The solutions of the equation 64x to the third plus 152x squared minus 62x minus 105 equals 0 are negative 5 halves, negative 3/4, and 7/8. If we look at the numerators of our answers, so that would be 5, that'd be 5, 3, and 7. Those are all factors of my constant term 105. If we look at the denominators, 2, 4, and 8, those are all factors of my leading coefficient 64. So that's essentially what my rational root theorem is saying. These observations are generalized by the rational root theorem. So with that being said, let's look at the actual definition of the rational root theorem. So don't let this throw you off. That's just a general form of our polynomials. This a sub n is just our leading coefficient. And this is our highest degree right here, x to whatever power our highest degree is. And then a sub 0 is just my constant term. This is just representing a general representation of polynomials. So don't let that scare you. So if our polynomial has integer coefficients.
Are we supposed to write this down?
You might want to have this down, yeah. If our polynomial has integer coefficients, do our integers involve fractions? Do integers involve fractions? No. It's just all my whole numbers and all my quote-unquote negative whole numbers are my integers. So if we have integer coefficients on our polynomial, then every rational solution of f of x equals 0 has the following form. My numerator of all my solutions are factors of my constant term a sub 0. My constant. Everyone know what a constant is? A number without a variable. Writing this down? Okay. And then my denominator, all my denominators of my answers are factors of my leading coefficient. So that'd be a sub n in this case. So all the solutions to my polynomial that has integer coefficients will be a factor of my constant term over a factor of my leading coefficient. Does everyone know what a factor is? A number that multiplies to give me that number. Now we do need to pay attention to this paragraph down at the bottom. The rational root theorem can be a starting point for finding solutions of polynomial equations. However, the theorem lists only possible solutions. So my list isn't going to be just a list of all my solutions. It's going to be possible solutions. In order to find the actual solutions, I must test the values from the list of possible solutions. And I'll show you how to do that when we get to that example. Questions?
What's under the A? It's like messing with my eyes.
Which A?
All of the one after P.
Okay, so this says f of x equals, it's a little subscript n, x to the n power. And this is a subscript 1, x, and then a subscript 0.
Okay, but what about P equals factor constant term A what?
a sub 0. So our constant term. A subscript 0. And then this is leading coefficient a subscript n. My leading coefficient. There we go. So once again, when I list out my factors of my constant term over my factors of my leading coefficient, that's just a list of possible solutions. And to get my actual solutions, I must test the values from that list of possible solutions. So, like we said at the beginning of the class, this is a very long and tedious process. It can be short and sweet if I get lucky and my first value that I start testing is a factor. Can I go ahead and move on? Okay, I'll give you a little more time. Let's do it. Find all real solutions of x cubed minus 8x squared plus 11x plus 20 equals 0. So in the past, we would have tried to factor this polynomial, set the factors equal to 0, right? To solve it. That's what we did in the past. Well, let's look at it. Do I have a GCF anywhere that I could factor out? No. Does this look like I could factor this using any of my factoring methods? No. I can't use any of my previous factoring methods. So essentially, the rational root theorem is just another method to factor something that I'm not able to factor. Okay, so I'm still essentially factoring it. So my rational root theorem wants factors of my constant term, and it wants factors of my leading coefficient, correct? That's what my rational root theorem wanted. So, what is my constant term in this case? What? 20. It's my number without a variable. So I'm going to list factors of 20. So what's the first number that goes into 20? 1. Does -1 also go into 20? Yep. So I'm going to put plus or minus 1. What's the next number that goes into 20? Plus or minus 2. Next one. Plus or minus 4. Next one. Plus or minus 5. Plus or minus 10. Bless you. And the last one? 20. So there's all my factors of 20. Everyone okay with that? Okay. So there's the factors of my constant term. Now I need the factors of my leading coefficient. So what's my leading coefficient in this case? 1. So I'm going to list factors of 1. What are they?
1.
Plus or minus 1. Is that all? Yep. So I've got the factors of my constant term. I've got the factors of my leading coefficient. My rational root theorem tells me that my solutions take the form, the factors of my constant term over the factors of my leading coefficient. So what I'm going to do is I'm going to take all my factors of my constant term and put them all over the factor of my leading coefficient. Okay? So I'm going to do plus or minus 1 over 1. Plus or minus 2 over 1. Plus or minus 4 over 1. Plus or minus 5 over 1. Plus or minus 10 over 1. Plus or minus 20 over 1. Does everyone see that? I just took all the factors of 20 put them all over the factors of 1. Everyone okay with that? So this list down here that I just made, this is a list of all possible solutions of my polynomial. So those are not all my solutions, those are just possible solutions. I now need to go through and test each one. I need to test positive 1. I need to test negative 1. I need to test positive 2, negative 2, until I find one that is a factor.
Oh boy.
Oh boy. Does anyone remember how to test something to see if it's a factor of something? Say that again. No, that's a good thought though. Anyone else have any ideas? How did we test something to see if it was a factor?
The little T-chart.
No, that's a good thought too though. How about synthetic division? You guys remember that? What did we want to happen if it was a factor? The remainder to be 0. So I'm going to use synthetic division starting off with positive 1 and just go in order till I find one that's a factor. So let's do positive 1. What are my coefficients that I'm using?
1, -8, 11, and 20.
Very good. That's just from my original polynomial. Okay? So bring my 1 down. What's 1 times 1? 1. What's negative 8 plus 1? Negative 7. What's 1 times negative 7? Negative 7. What's 11 plus negative 7? 4. 1 times 4? 20 plus 4. So is positive 1 a factor? It is not a factor. So now I have to go and use synthetic division with negative 1. Oh man. I just got to keep doing this until I find one that has a remainder of 0. It's good stuff. No. Bring my 1 down. What's negative 1 times 1? Negative 1. Negative 8 plus negative 1. Negative 9. Negative 1 times negative 9. 9. 11 plus 9. 20. Negative 1 times 20. Negative 20. 20 plus negative 20? 0. Is negative 1 a factor? Look at there. We got lucky. It was the second one. Look at that. Look at us go.
We had to go through every single.
Yeah. Sometimes you get lucky, and it's like the first or second one. Sometimes you get unlucky. You might have had to go through until you got to negative 20.
Do you have to go from the order from the first line?
No, you can start whatever order you wanted, but that would have kind of stunk if I started at negative 20 and worked my way backwards, you know, because it was negative 1. So, sometimes you get lucky, sometimes you don't. So, how would I represent negative 1 as a factor? Would I put it as x plus 1 or x minus 1? What? I heard minus and I heard a plus. Oh, you said minus? I heard minus. Minus. Does everyone agree with x minus 1? Are we sure?
Oh, no, x plus 1.
It is x plus 1. Because remember, it takes the form x minus k. So if I plug negative 1 in for k, it'd become x plus 1. Is everyone okay if I erase my factors up here? So it'd be x plus 1. What's my other factor over here? Based on my synthetic division that I got. Everyone okay with that? Still not done yet because I got to find all the real solutions. But does this look like something I can factor like my old factoring ways? Yes, it does. So let's try to factor that real quick. Everyone okay if I erase everything at the bottom? Make sure we're awake. Our heads are up. See a few people nodding off. Pay attention. Okay, so I'm going to make my T-chart. I'm going to create my sets of parentheses. What's my variable? My variable? X. What are my two signs? Huh? Negative, negative. If this is a plus sign right here, it tells me they're the same. If they're the same, this sign tells me what they are. So they're the same, they're both minus. Does everyone see that? What goes in the first slot of my T-chart? 20. Second slot? Negative 9. What are the first two numbers that multiply to give me 20? Negative 1, negative 20. Next two numbers? Negative 2, negative 10. Negative 4, negative 5. Is that all? What's negative 1 plus negative 20? Negative 21. Negative 12. And negative 4 plus negative 5. So which two numbers is it? Negative 4, negative 5. Plug those in to my parentheses. Almost there. Almost there. How do I now use this to find my solutions to this polynomial? Do what? Yep. Let's set each factor equal to 0. This one I already know is negative 1. I found that earlier. Here I'm going to add 4 to both sides. Here I'm going to add 5 to both sides. So my three real solutions of my polynomial are negative 1, 4, and 5. And that I'm done now. That's my answer. Does everyone see that? So I was able to get to my answer even though I couldn't factor like I originally factored by using the rational root theorem. Okay? Now, I want you to look at something real quick. My solutions were negative 1 over 1, positive 4 over 1, positive 5 over 1. Were those all on my list that I created? Yep. 1, 4, and 5 are factors of my constant term. 1, 1, and 1 are all factors of my leading coefficient.
Imagine if you had 100 positive factors and 100 negative factors.
That'd be crazy.
And you don't find the answer until you go through all 200 factors.
Yeah, that would stink, wouldn't it?
That would really stink.
Yep. Are there any questions on this first example?
That happened.
Any questions? All right, let's move on. It's going to get harder. In example 3, the one we just did, the leading coefficient of the polynomial was 1. That was really, really nice because the only two factors of 1 were positive 1 and negative 1, correct? What happens, though, when the leading coefficient is not 1? We're going to have more factors, aren't we? So, if the leading coefficient is not 1, the list of possible rational solutions or zeros can increase dramatically. You're going to get a lot more numbers. Your list is going to get way longer. In these cases, the search can be shortened by using a graph, and I'm going to show you how to do that on this next example. It's still going to take a while, but it's not going to take as long as it would if I didn't have my graph there to show me. Okay? So here we go. Find all real zeros of f of x equals 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12. Do I have any GCFs I can factor out? No. Can I factor this using any of my other factoring methods? No. So what must I need to use? A rational root theorem. What's my constant term?
12.
12. So I'm going to list factors of 12. We already did that earlier, didn't we? Can I go through them pretty quick? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Everyone okay with that? There's my factors of my constant term. What's my leading coefficient in this case?
10.
10. So now I've got to list factors of 10. So plus or minus 1, that's always going to be one of your factors. 1 will go into every number. What's the next one?
2 minus
2,
5.
5, 10. So now, for my list of possible solutions, I have to put my factors of 12, every factor of 12, over every factor of 10. So I'm going to put all of these over 1, then I'm going to put them all over 2, put them all over 5, put them all over 10. So that's why our list is going to increase dramatically. Does that make sense? So we have more numbers to put our other numbers over. So make sure our heads are up. We're all ready to take on this task. Make sure we're awake and paying attention. So I'm going to get 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 12 over 1. Everyone okay with that first group? I put them all over 1, so I'm now done with that 1 on the bottom. Now I've got to put all those factors of 12 over the next factor of 10, which is 2. So I do 1 over 2, 2 over 2. What does 2 over 2 reduce down to?
1.
1 over 1. Is 1 over 1 already on my list?
Yes.
Yes, so I don't need that 2 over 2. I don't need to list it twice. Okay? Plus or minus 3 over 2. Plus or minus 4 over 2. Is that one already on there? Yep, that'd be 2 over 1. Plus or minus 6 over 2. Is that already on there? Yep, that's 3 over 1. Plus or minus 12 over 2. Is that already on there?
Yes.
Yep, 6 over 1. I'm now done with the plus or minus 2. Everyone still with me on that?
I really do not like this.
It's okay. Now I've got to put them all over 5. Plus or minus 1 over 5. Is that already on there?
No.
Nope. Plus or minus 2 over 5. Plus or minus 3 over 5. Plus or minus 4 over 5. Plus or minus 6 over 5. Plus or minus 12 over 5. I'm now done with that 5 on the bottom. One more. Got to put them all over 10 now. So plus or minus 1 over 10. Is that already on there? Nope. Plus or minus 2 over 10. Is that already on there? Which one is it? 1/5, so I don't need it. Plus or minus 3 over 10. Is that already on there?
No.
No. Plus or minus 4 over 10. Is that already on there?
Yeah.
What is it? 2/5. I don't need it. Plus or minus 6 over 10. Is that already on there? 3/5. Plus or minus 12 over 10. Is that already on there? What? What is it? 6/5.
I'm surprised that you had enough room for
Right?
factors.
Right? Pretty impressive, huh? So there's my list of possible solutions, possible zeros for my polynomial. Now, like I said on this slide, In these cases, the search can be shortened by using a graph. Here's what I mean by that. Let's go look at the graph of this polynomial. Here's the graph of my polynomial. Okay? Where are the solutions of this graph? Where it crosses the x-axis, right? Or where it touches the x-axis. So that'd be here, 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 and here. What I'm going to do is I'm going to estimate those points on the x-axis and see if they're in my list. If they're in my list, then I'm only going to test those points on the graph. So I'm going to be testing only 3 or 4 instead of however many is on that list. Does that make sense? And hopefully my guess will be close enough, or it'll be accurate enough that it'll be correct. So let's start with this first point where it crosses the x-axis. It's between -1 and -2. So what point is that?
0, negative 1.5.
Negative 1.5. How can I represent that as a fraction? How can I represent that as an improper fraction? Negative 1.5 is an improper fraction. Negative 3 over 2. Is that one of the numbers on my list? Yes, it is. So I will test negative 3/2 out using synthetic division. What about this next one? What does that look like it's at? Negative 1/2, right? Is that number on my graph or on my list? Yes, it is. So I'll test that one too, if negative 3/2 doesn't work. What about this one right here? Positive 1/2. That's what it looks like to me. Is that on my list? I'll test that if my first two don't work out. And then my last one right here, what does that look like? 2.5, or that would be, what is an improper fraction? 5 over 2. Is that on my list? It is not, so I won't test that one out. Okay? So hopefully, one of these 3 that I've estimated will be a factor. Okay? So let's just hope it is for now. So let's start with negative 3/2. Let's test negative 3/2 using synthetic division. Will someone read off my coefficients for me? Negative 42. And 12. So there's my coefficients of my polynomial. Hey, stay away. Stay away. Bring my 10 down. Does someone have a calculator handy? Negative 3/2 times 10. Negative 15. Negative 11 plus negative 50. Yes.
Wouldn't it be positive 3/2?
No. Because that's negative 3/2 on my graph, right? So if negative 3/2 works, then I would make it x plus 3/2 as my factor. Does that make sense? Did I answer your question? I don't change the sign on here because I'm testing out the point negative 3/2 because it's to the left of the y-axis. Does that make sense?
Yeah. I just don't understand because like you have to count like what we did on the other example with the we changed because the k needs to change.
Right. So I said negative 1 was a solution. So my graph would have crossed at negative 1 on my x-axis. But I just represented it with x plus 1. Does that make sense? So we're testing the number negative 3/2. If it is a solution, we'll put x plus 3/2. Okay? Okay, negative 11 plus negative 15. Negative 26. Negative 3 halves times negative 26. It'd be positive 39, right?
Yeah.
And then negative 42 plus 39. Negative 3. Negative 3 halves times negative 3. Nine halves. 7 plus 9 halves. 23 halves. And then negative 3 halves times 23 halves would give me negative 69 over 4. And then 12 plus negative 69 over 4 would give me negative... Say that again.
Negative 117 over 4.
I don't think that's quite right. But it does give me some number other than 0. So it's negative 3 halves a factor, a solution.
It's negative 21 over 4.
Negative 21 over 4? So negative 3 halves is not a factor. So what was the next value we were going to test based on the graph? Negative 1 half. So let's try that out. So it was 10, negative 11, negative 42, 7, and 12. Testing negative 1 half out with synthetic division. Bring my 10 down. It's negative 1 half times 10. Negative 5. Negative 11 plus negative 5. Negative 16. Negative 1 half times negative 16. Positive 8. Negative 42 plus 8. Negative what?
34.
Negative 34. Negative 1 half times negative 34. 17. 7 plus 17. 24. Negative 1 half times 24. And 12 plus negative 12. Hooray! We did it! Is negative 1 half a factor? It is a factor. So how can I represent negative 1 half? X plus 1 half. And what's my other factor?
10x cubed minus 16x squared minus 34x plus 29.
Plus 24. Everyone okay with that? Everyone still with me? Does everyone see how that was a lot easier than me just going through positive 1, negative 1, positive 2, negative 2, so on and so forth? I was able to look at the graph, kind of estimate where my zeros were, and test those solutions to see if they were factors. But I'm not done yet. I got to keep going. So do I have any GCFs in this polynomial now? 2. So let's factor out a 2. So 2 times what will give me 10x cubed? 5x cubed. 2 times what will give me negative 16x squared? Negative 8x squared. 2 times what will give me negative 34x? Negative 17x. And 2 times what will give me 24? 12. Everyone okay factoring out that 2? So I don't lose track of this 2, just kind of floating around in the middle. I'm going to go ahead and distribute it through this binomial. Everyone okay with that? just so I don't lose it, I don't forget about it. I'm going to distribute it through. So what's 2 times x? 2x plus 1. 2 times 1/2 is 1. Now I have 5x cubed minus 8x squared minus 17x plus 12 equals 0. Okay, do I have any other GCFs to factor out here? I do not. Does this look like something I could factor using my other factoring methods? No. Interesting. So what do you think I need to do now?
You have to do another one of those things?
What things?
Whatever we were just doing.
What is it? Huh? What theorem? Rational root theorem? Y'all are correct.
We have to do another?
We got to do rational root theorem now for this polynomial because we cannot factor it. Yay! This is good stuff, isn't it?
That's why they didn't get through it.
So I've got 2x plus 1 times 5x cubed minus 8x squared minus 17x plus 12 equals 0. Whew. Golly.
What's it called again?
Rational root theorem. So now I've got to list factors of this new constant term 12 and factors of my leading coefficient 5 and start testing things out again. Okay? We have about 5-ish minutes left of class, so we're going to finish this tomorrow. Okay? So are there any questions before I end the recording for today?